A very good afternoon to all of you. Welcome to Black Slides. This is your secondary school online. This is your secondary school online. School ndio mwei. This is your school. Alright, so my name once again is Mr. Pochilola, your teacher on this platform. We are excited to have you on this platform, on our YouTube channel, as well as in the main classroom. If you have just joined the channel today, consider subscribing. If this is the first time you are watching this lesson on YouTube channel, consider subscribing so that every time a new video lesson is uploaded, you become notified. At Black Slides, we settle for nothing less than distinctions. Our target is to get 100 distinctions in the coming Msce exams. Alright, cumulatively, when you add all the distinctions in chemistry, biology, and physics, as well as mathematics, we would like to have not less than 100 distinctions, and we are working hard on it, making sure that this becomes a reality. So as long as you are learning here on YouTube, learning is at no cost. But should you want to get extra support in terms of notes, exercises, books, homeworks, even exams, don't hesitate to enroll into our main classroom by simply sending us a message. This message here on these two numbers, we shall be able to come back to you and address your concern. If you have access to email address, don't hesitate to send me an email on blackslides@gmail.com. So welcome once again to Msce Physics. We continue looking at detection of nuclear radiation. Detection of nuclear radiation. Remember that there are three types of nuclear radiations, namely alpha, beta, and gamma, and that these three are not visible, and they are odorless, meaning they are smellless, you can't smell them, which poses a very huge danger. If you can't see them, you can't smell them, it is difficult for you to tell their presence. It's difficult for you to know whether you're exposed to them or not. Therefore, we need to find means of detecting their presence wherever they exist. Alright, so far in our previous lesson, we looked at two methods of detecting nuclear radiation. Namely, we looked at the GM tube, the J-Jamure tube, how it works, and the photographic film. Make sure you know to explain fully how each method works. If you missed that lesson, please go back to it and learn. Today we are going to discuss different types of detection methods, namely use of the cloud chamber and the scintillation counter. So, this lesson intends to achieve the following objectives. By the end of this lesson, you, the students, should be able to define nuclear radiation and explain why detection is important, why we need to detect nuclear radiation. Describe the principle of operation of scintillation counter and cloud chamber, and then compare the two detectors in terms of their functions, applications, and limitations. Interpret simple diagrams showing how each detector works. Relate the use of these detectors in real-world applications such as medical imaging, nuclear safety, and physics research. Alright, so these are the key objectives the lesson intends to achieve. Welcome once again. My name is Mr. Paul Chilola, your teacher. We are passionate about seeing you excel academically. Invite your friends, wherever they are, to come and join us. Alright, whether as full-time students on our online class or as a full-time subscriber to the channel, so that you don't miss on anything. You can cover these things fully while you are at home. Alright, whether you are upgrading yourself, you want to sit for Msce one more time, you are working, these lessons are meant for you. Whether you are at school and you're on holiday, you are also welcome. So ask for a phone, or tablet, or iPhone, or iPad, or tabloid from your parents, so that you can join our classes. The YouTube channels are totally for free, but our paid app classes will require you to make a small contribution of only 18,500 per term. Not monthly, but per term. That's quite mean, alright, and cheap, making education as affordable as that. Here we give you the best. Alright, so a brief introduction to the lesson. Nuclear radiations such as alpha, beta, and gamma are invisible. They are invisible, meaning you cannot see them with your naked eyes. But at the same time, they are dangerous. Therefore, we need to detect them. So special detection methods are needed. The two common detectors are scintillation counters and cloud chamber. So this lesson is going to look at these two methods. When we have fully covered a discussion on these two methods of detecting radiation, it means we shall have a total of 4 methods. Alright, we have a total of 4 methods, namely use of the J-Jamure tube, GM tube, the photographic film, then scintillation counter and cloud chamber. We shall have one more, which is the use of the gold leaf electroscope. Gold leaf electroscope, which is a technique again used to detect nuclear radiations. Alright, so welcome once again. Please invite as many of your friends as possible to join this channel. Don't be left out. Don't be left out. We want you to pass, and pass very well. We have done this before from 2023 to date. The past exam years, we have had our students passing with very good grades and distinctions, and they are already selected in public universities. And that's our wish, that as many of you as possible, you should also join public universities through us. Alright, so we are going to discuss these two in order. So we start with scintillation counter. The scintillation counter is simply a simple device that can be used to detect nuclear radiation. It works on the principle that certain crystals, known as scintillating material, for example, an example is sodium iodide, will emit flashes of light which are called scintillations, when struck by radiations. So we are saying the scintillation counter works on the principle that certain crystals, not all crystals, but certain crystals, an example of such crystals is sodium iodide, will emit flashes of light. Those flashes of light are called scintillations when struck by radiations. Very important point. Alright, so sodium iodide is the NaCl. Sorry, not NaCl, but NaI. It is a crystalline substance. It's a crystal. Alright? Sodium is a group 1 element from your chemistry, from periodic table, while iodine is a group 7 element. Therefore, it is a salt, which is crystalline in nature. It is called the sodium iodide, such that when it is struck by radiation, be it alpha or beta or gamma, it is going to emit some flashes of light, which are called scintillations. Alright? So that's the principle in which it works. How does it work? So first of all, radiation enters the crystal, and the crystal produces tiny flashes of light. These tiny flashes of light are called scintillations. Alright, then if there is what is called a photomultiplier tube, which converts the light, the flashes of light, into electrical pulses or electrical signals. Another word for these pulses is signals. Alright. And the pulses or the signals are counted electronically, giving radiation or the amount of radiation which is available or which is being detected. So 1, they'll ask you to describe the working, how a scintillation counter works. So radiation enters the crystal, the material known as the scintillating material. An example is sodium iodide. Then the crystal begins to produce flashes of light. Those flashes of light are counted, are converted into electrical pulses or signals. Then the pulses or the signals are counted electronically to give the intensity of radiation. You should be able to write this in 5 marks question. Describe in short. Briefly describe how a scintillation counter works. So this technology can be used to detect gamma rays. So the method is very effective for detection of gamma rays, and it is used in medical imaging, alright, for scanning body parts. It can also be used in nuclear research and in places where people work with nuclear radiation. It can be used to monitor the level of radiation. However, like any other method of detecting nuclear radiation, the scintillation counter has 2 main limitations or weaknesses. Alright, one limitation is that it requires electricity and very sensitive electronics. For that reason, it is expensive compared to other techniques such as the GM tube and the photographic films. I hope that is in order. Once again, welcome to the channel where you learn the sciences for free. Please, if you don't have a phone of yourself, ask your beloved parents to get you one phone. Even a small phone can do. Alright, for example, I'm using a very cheap phone to prepare you these lessons, which is called the A90. It's an Itel phone. They are available in the market. They are very good phones for learning online. A90 or A100 if you have enough money, or any other Android phone can work just as good. So ask your parents to get you a phone so that, not to play on it, like to be on WhatsApp or to be Facebook on social media, but to learn from Black Slides Online Secondary School. Here at Black Slides, we don't encourage misbehavior on social media. We want our students to be responsible, to use their phones responsibly to learn, to prepare for their exams. Alright, so welcome once again. My name is Mr. Pochilolo, your teacher on this platform. If you'd like to join us on our main classroom, don't hesitate. All you have to do is ask us on the numbers that we shared with you earlier on. Ask you to join. How do you join? The main classroom. Once again, welcome. Alright, so this is a schematic diagram of the scintillator or the scintillation counter, a device that is used for detecting radiation. Alright, so in the first place, we must have the material that can emit radiation. So we have such a material here. Alright, this can be anything like uranium, alright, or it can be any radioactive substance. So uranium is an example, polonium is another one, strontium is others, cesium, radium, and other materials. Okay, so you have a material here which emits radiation. Alright, so it emits radiation. This is radiation over here being emitted by the radioactive material. Alright, so when the radioactive material is emitted, it will interact with the scintillation material. An example of scintillation material is what is called sodium iodide. Sodium iodide. Alright, and inside it is fitted with light reflectors. Okay, so we have flashes of light due to the interaction between radiation and the scintillating material, or scintillation material. Alright, so this light strikes a very sensitive material, photosensitive surface. Alright, and the inside it is fitted with a photo multiplier or amplifier, if you like, which converts this into signals that can be detected electronically. So these signals are sent to a counter where they are counted as amounts of radiations present or being emitted by the source here. Alright, so relate the diagram to what we have discussed so far. So we said that radiation enters the crystal, sodium iodide, and the crystals produce light flashes of light, and then a photo multiplier tube converts light into electrical signals, These signals are counted electronically to give the amount of radiation. Please know the diagram and use it to describe the process. In case the examiner is asking you to answer a question that says, with the aid of a well-labeled diagram, explain how scintillation works to detect nuclear radiation. Welcome to the next one, which is the cloud chamber. The principle in which the cloud chamber works is that radiation ionizes air molecules. Alright, so it has air molecules which, when exposed to radiation, the air molecules will become ionic. That's a process called ionization. So in a supersaturated alcohol vapor, ions act as condensation centers, forming visible tracks. Very, very important to note. So we have supersaturated alcohol vapor where ions are formed to act as the condensation centers. Alright, so the vapor is condensed and the ions facilitate that condensation. To condense means to turn vapor into liquid, as you might be aware, forming visible tracks. Tracks are something like this. So you have something like this. These tracks indicate the amount of radiation that is there. If it is alpha radiation, the tracks are very, very dense. They are very dense. You see these lines are very dense. Or if it is beta, the tracks are a bit faint. They look like this. Right? These are tracks, and none at all for gamma rays. Alright, so we are saying the principle on which the cloud chamber works is that radiation ionizes air molecules. So in a supersaturated alcohol vapor, the air ions act as condensation centers, where the vapor turns to liquid, or better still, solid, which forms tracks, visible tracks. Alright, the working of a cloud chamber is in such a way that the chamber is cooled, often with dry ice. Dry ice is frozen carbon dioxide. Frozen carbon dioxide. In case you are asking what is dry ice, this is frozen CO2. Right, it's the one that is used as a cooling agent. Then the supersaturated vapor is introduced. As a result, radiation will pass through to ionize molecules, to turn them into ionization ions. Then the vapor condenses along with ion paths, forming visible streaks or visible tracks. In the chamber, one should be able to see something like this, lines, something like lines. So the density of the lines, the intensity of the lines will decide the type of radiation being detected. So sometimes they can be as faint as this. Alright, to show the intensity of radiation. Alright, very, very important. I'm sure we are together. So the working of the cloud chamber is such that the chamber is cooled with dry ice. Dry ice is frozen carbon dioxide. And then the saturated vapor is introduced. Radiation passes through and ionizes the molecules that are present in there. Then the vapor condenses along the ion path, forming visible tracks. Alright, so this technology can be used to show tracks of alpha and beta radiations. We shall have short, thick tracks for alpha and long, thin tracks for beta. And now, and none for gamma, because remember that gamma is less ionizing. So this method works best for radiations that are ionizing. So we are saying for alpha, you have tracks like this that are short. So this is alpha tracks, okay, the streaks left behind by alpha, but we shall have this kind of shape or streaks or tracks for beta, and none at all for gamma, because gamma is the pure radiation, which does not ionize matter. All right, very important. So it shows tracks of alpha, beta particles, and for you to tell which is which, short, thick tracks for alpha and long, thin tracks for beta. Once again, you'll observe something like this. For alpha, the lines are thick, but for beta, the lines are thin. Alright, so watch out, the examiners can ask you to identify the type of radiation that was detected by simply giving you the lines, the shapes of the tracks. The shapes of the tracks will tell how much radiation and as well as the type of radiation that was being detected. So the method also helps to visualize particle motion and study radiation properties. Like other methods of detection, this method cannot be used to measure energy precisely, the energy generated by the radiations, emissions of radiations. The method requires a careful setup and the cooling. So these are short falls, Yeah. So where cooling does not exist, it is difficult for us to use such a technique. It is very, very difficult. Alright, so the setup looks like this. This is the setup. Okay? So like we said, there's dry ice, which cools the alcohol vapor until it is saturated. Alright? And then below here there's foam, which is used to support the dry ice. Dry ice is just carbon dioxide. And then there's a lamp here. This is glass. So the lamp is used to help us to observe, to make observations inside, to provide light, which is adequate enough to help us make observations inside. And then we have radioactive source. That's a substance that produces radiation and cause ionization of the vapor. Alright, so we have, this is a source of radiation. Like I said, the radiation can come from any substance, radioactive substance, such as uranium, polonium, cesium, or strontium, and any other material. Alright, so the radiation, once it enters the chamber, it's going to form streaks of the tracks to show the intensity of radiation, be it alpha or beta. Okay, it also has a lid here with plastic and transparent for you to make observations through it. Then there's a fat ring which is soaked in alcohol to supply alcohol vapor to the chamber. And then we have alcohol vapor where being condensed to form liquid droplets around the ionized molecule. So these are the tracks that we are talking about. The intensity of the tracks, the thickness of the tracks will tell you how much and the type of radiation under examination, under observation. Alright, so once again, you should be able to draw the diagram and use it to explain how the cloud chamber works. From the discussion we had in the previous slide, you can relate the diagram to what is being discussed here. Alright, so there are two types of tracks that can be observed in a cloud chamber. The alpha particle tracks will be shown by thick, short, straight lines. Alright, so thick, straight lines like this will show that the radiation being studied is alpha radiation. But for beta radiation, we shall have thin and long curved lines, something like this. Alright, so this is an indication that the radiation is beta radiation. Beta radiation. Once again, welcome. Welcome to the channel. This YouTube channel is for you to learn from, to prepare fully for your exams. Once again, my name is Mr. Pochilola, your teacher, a very passionate teacher, passionate about your success. Your success is my dream. When you succeed, you pass very well. Wow, that makes me more than happy. That makes me more than happy. I'm here for you. In case you have questions, don't hesitate to leave a comment in the comment section below, and we'll be glad to come back to you to guide you accordingly. Now, let us compare the two. We are going to compare the scintillation counter and the cloud chamber in terms of detection method. Alright, so the scintillation counter uses flashes in a crystal, light flashes in a crystal, while the cloud chamber uses vapor being condensed on ions. This method is best for scintillation counter is best for gamma rays radiation intensity and is not suitable for alpha and beta detection, while cloud chamber is suitable for alpha and beta particle tracks. Alright, the output being detected is electrical signals or electrical pulses, while the cloud chamber, the output is the visible tracks. Visible tracks. Visible tracks cannot be measured. You can just see them, observe them, but you cannot measure the exact amount of the radiation. This is applied in medical imaging, nuclear safety, and this one is used in demonstrations in class, in a physics class, in particle physics. Limitations of the scintillation counter is that it is expensive and it requires an rigorous electronic setup, while cloud chamber needs cooling, no energy measurement. It doesn't measure energy. So know these comparisons between the scintillation counter and the cloud chamber. Once again, my name is Mr. Pochilola. Please contact me on the numbers shared earlier on in case you have questions, how you can join the classes. It is so easy. All you have to do is, if you'd like to join our online classes, which are offered on Google Classrooms, you simply have to make a small contribution of 18,500. You can pay that amount in 2 installments if you like. there's no problem. Alright, so once again, welcome. If you are learning on YouTube, consider subscribing to the channel, hitting the notification bell, so that every time I upload a new video lesson, you become the first one to be notified. Alright, before I go, I'd like to leave you with questions to work on, and you're supposed to show me you are working by simply taking a picture of your work and share it with me to the numbers shared earlier on. Alright, so question number 1 is based on the scintillation counter. What is the principle behind the operation of the scintillation counter? Alright, so draw a label diagram of the scintillation counter. These things you should be able to do, okay, so that we are going to confirm that we have learned and mastered the content. Explain the function of the photo multiplier tube in the scintillation counter. We have discussed this in the lessons. State 2 advantages and 1 limitation of using a scintillation counter in detecting nuclear radiation. So look at these questions on your paper 1 of physics. They can be potential examination questions. Remember that the questions are exam style questions. Based on the cloud chamber, describe how a cloud chamber detects nuclear radiation. Explain why alcohol vapor is used in a cloud chamber. Why? Alright, so go back to the material that is covered and say the reason why. Distinguish between the tracks formed by alpha and beta particles in a cloud chamber. Remember, for alpha particles, for alpha radiation, the tracks are short and thick, while for beta, the tracks are long and thin. State 1 limitation of a cloud chamber as a radiation detector. Limitation, Alright. And lastly, compare the scintillation counter and cloud chamber in terms of type of radiation detected, in terms of output produced. Remember, in one, the output is simply the flashes of light, and in the other, it is the tracks. It is the tracks. Alright, then practical application. Suggest one situation where a scintillation counter would be preferred over a cloud chamber and explain why. These are exam style questions. Alright, don't waste time with the social media. Use your phone responsibly to learn from us. Here at Black Slides, we make sure that you learn and learn very well online. My name once again is Mr. Paul Chilola. Go and subscribe. Subscribe to the channel. Don't delay. Don't delay. You are losing out. You are missing a lot. Subscribe to the channel once again. Bye-bye. Expecting to see you again. The happiest teacher online. My name is Paul Chilola. Once again. Bye-bye.